And now the last of the four. So this one is actually 6 triangles as seen right here. So the first pro is that, unlike the first three, it's full of edge loops. So I can go over here and yeah, you have one like this. In fact, this one in Pacific actually has an entire edge cut in half. And because I can actually do this, just delete this one face along its vertices, and then use the mirror modifier like so. Except I should do one that is actually parallel to that one axis. So let me do it again. Okay, so now that it's parallel to the horizon, I can just do this and go to Y, and there you go, exactly the same. But anyways, so that's one pro. Another one is that because it has triangle faces, it actually makes triangulation easier though. So I can go over here and yeah, so because they're already triangles, it doesn't have to do anything there. It's only the sides, the rectangles, that has to split in half each to make them triangles. And you know, with game engines, it makes everything in triangles anyway, so this is ideal for that. And of course, the third pro is that, actually I think it's a fourth pro. Yeah, so the last one is going to be actually this. So if I turn this on, and let's say I want to make it like this. So what I can do is, I can just grab this up, and then I could just do this. Actually, I can just do this right here, and scale it down. And I can see that it makes it a lot sharper. So if you want that, you can do that. And so now for the cons. Except one more thing I forgot. So another pro is that, like the first one, it actually has full symmetry, so I can just rotate 6 degrees and exactly the same. So now I go to the cons. And now for the cons. So the first one is that, if you look over here at the top, you actually have stretching just like the first one. In fact, if you remember the first one, you know, the one hexagon face, it actually has a very similar topology to the 6 triangles, because look over here, you actually have this. And so that means that you have it do this. The second one is that, if I go to edit mode, yeah, so right here, you have 14 vertices, 30 edges, and 18 faces. So of the 4, it has the highest poly count, which is not good for performance. And then the third one is going to be that, if I undo, you see how it looks flat over here? Well, to fix that, you actually have to do this. Go to edit mode and then pull this up. Or a better way is if I were to go to my shape keys and then do this. So that's how you make it round like this. And of course, if you turn off the subsurf, you make elongated hexagon by pyramid. That's what this is. So you can think of it as a pyramid with a hexagon prism, and then an identical pyramid on the side. The fourth one is that it has only one face loop. So if I go to edit mode, so if I do this right here, that's the only face loop it has. That's because it's the only one that has, well, it's only faces that have even number of sides, because triangles have 3 sides, and that's odd numbers, so it's not going to work. So if I try to do a face loop, it's not going to work. Now with the hexagon, but you know, the first one, it doesn't work because of the way Blender is programmed. But here, it's a topology's fault and not just a program, because where would it go? Like, we have to go either here or here. It can't go straight because that's a corner. So that's why I return it there anyways. And the last con is this. So even though it's full of edge loops, I can select this one right here and this one, but I can't do this because although it selects these 3 edges, it won't select the other side, so I have to select it both same time to get an edge loop. So this one is also not the topology's fault. It's actually Blender way of program. So just like the face loops, same thing with the edge loops too. So basically, Blender is biased towards 4-sided polygons and 4 edges to a corner. So that's all the pros and cons for the 4 prisms. So now you have these 4 prisms again, and you can see the different topologies of each at top view. So you can see that this one, along this, you have stretching, this one has compression, and this one has no distortions. And now I'll show you why. But first I have to select everything here, and then turn this down to, let's say, 0, and then go to this. Well, so what I did was I went to Object, Make Links, and then Modifiers, so that everything has the exact same settings with the modifiers. So now I basically have it turned off. So you can see that you have these triangles. So what it does is it just takes the midpoint of each edge, goes to center, and then it goes to the midpoint of each neighboring edges until it's all complete. And so if I do 1, you can see that, let me go simple first so you can see easier. So we'll do 0, and then 1, and then 2, and 3. So that's what happens. So let's just go to 1, for example, with everything here. So yeah, and that's why when you have the triangles, you actually have these deltoids. And then with the hexagon, you get the exact same deltoids, only they're facing opposite direction from the center. Actually, no, in this case, it's the same direction. Yeah, in fact, these two is 60 degrees. These two are 120 degrees. And of course, these two plus these two are 9 degrees. So exact same shape. And now you can see why the 6 triangles and the 1 hexagon makes the exact same shape with the subdivision surface modifier here. And of course, with this right here, it's a different one because with these being quads, you get to have an edge that goes to the center and then to the other side. In this case, you don't have any bending, and then same with this. Now the trapezoid here, well, it's 90 degrees here, but it's 60 and 120 degrees here, because that's what kind of trapezoid this is. So as I increase it, you can see that it makes this pattern right here. And now let's just make it look smoother. So if I do that, and then do this again, so now you can see why that happens. And of course, the reason why it works best in here is because if you look over here, you don't actually have a pole. Like, you don't have a vertex that has a different number of edges than 4. You can pretend this is 2, but it's just 1 edge. So, like, because there was 2 though, then it would look like this. Yeah, it looked weird. So I'm not going to do that. So I'm going to undo that until it gets back to normal. And there you go. And now I'm going to do another section. And so basically, which one to use? Well, let's see. So this one right here, the one hexagon, is best for lowest geometry, as in smallest file size, and also best for rounding things off easily. This one is best for the best square grid you can get. This one is best to make a rhombic dodecahedron, as this one right here. And this one's best for having better pointedness, so I can do this. If I select this one right here. Yeah, it's best for that kind of stuff. So that's it for the different topologies on the hexagon prisms. Actually, no, because I've got to show you why I chose hexagon, not the others. So now I'm going to be back. And now I just duplicate one of these hexagon prisms. I chose this one because it has the best topology for what to do. First, I did remove that shape key thing, so now it's just a prism. So if I do this, it's just that. But now, what I showed you earlier is if I take this edge loop and dissolve it, I get a square prism, but never tiny prism if you view it from there. To make it square though, all I have to do is go to here, type S for scale, X, and I'm going to paste the square root of 3, and now it's exactly a cube. Or you want to call it square prism, that works too. Now I do this. So yeah, now you see why I didn't do the square one, because there's really only one usable option. I could also do this, where if I just take these edges, take these vertices and then join them together, and then do this too. But then it makes a weird shape. And the only use I have for this is if I were to rotate this, like, let's say 45 degrees. I actually want to do that. I shouldn't do that direction. I'll do this one instead. Okay, so now I can just go over here, rotate 45 degrees, and then I'm going to take these two vertexes and I'm going to delete them. Now go to the mirror modifier, also on the Y, and move up so after merges. And yeah, that's the only use I have for that. But otherwise, I'll just stick with just the standard one single face for the square. Now, for the other ones, that's coming next. And here's when I go above 6. So if I go over here, so I'm just going to take, let's see, this one right here. Let's go to face select actually. And I'm going to subdivide it. And yes, it makes that. But I don't want to have these vertices here, so let me just get rid of them. And of course, there's an add-on I have where I have, let's see, where is it? Where is it? Oh yeah, loop tools. Yeah, so as you go to edge mode here, so I can do this, and press circle, and now I'm making a regular octagon. So yeah, now you can see why I didn't do octagon prism, because that looks kind of weird. You see on a hexagon, it's not too bad. It looks pretty normal, but when you get the octagon, it starts to look kind of weird. You think that's weird though? Let's try this one. So now I'm going to take these two faces, subdivide it, and then of course, don't select these faces like that, and go to circle, and so now you have a dodecagon, and you can see it's even worse than this one. So basically, when it comes to prisms with only one face, I want to go to higher than hexagon, because you can see this one looks fine, this one looks kind of weird, and that one, yeah, it becomes very distorted. And so now you know what happens when you have different topologies on hexagon prisms, and hopefully you know which one to use in your projects and stuff. So that's it